This is a series of videos that tell the story of how my father and I came up with the four universal motions in physics. We highly recommend that you watch these videos in order. Enjoy. My father came up with a solution to one of the biggest problems in physics. He made light from waves of particles. Could everything be made up of particles? Stay tuned and find out. Hey, Dad, how you doing?
I'm doing well. How are you?
Pretty good, pretty good. So our first video, we talked about how you solve one of the greatest problems in physics, the wave-particle duality, and you came up with this particle model for light. After that, the second obvious question was why you and why nobody else? And we talked about that, and basically from your background of electrical engineering and you hanging out with all these physicists who are working outside the mainstream. Then once we got that, I kind of got in my head, okay, I've got this new thing that was a big aha moment. We remember in the first video, I went nuts because when I understood what you were doing.
Oh, this is perfect. You got to keep it steady. Right?
Oh yeah, you do. He does much better. But that got me the idea of what he meant by his model for light. So I had to start really letting this roll around in my head. And over the many years I hung out with dissident physicists, I started to piece together maybe other ways that particles can describe things in the universe. In fact, can particles describe everything in the universe? Not the same particle necessarily, but at least just the idea that a particle model. I almost said particle model. So let's take a look. If we go to formmotions.org, you can see what we have, the four motions. And yeah, you may know about this already, but if you really haven't looked at it, you can go there. But this is what my father came up with. And so the next logical question was, okay, what else do we know? Well, obviously this kind of came from, because we were making the movie Einstein wrong. We were doing an experiment to try to show that gravity was a particle. So obviously gravitic motion was already there. That idea was not our idea. That idea had been around for a while. Now, of course, mainstream physics doesn't believe in any of this. They don't believe that gravitic motion or random particles moving in random directions. But when I looked at it, I said, well, that seems to be a model for gravity using particles. So we have the waves of particles making light, and now we have gravitic motion. And of course, if you don't know about how this can work, this model can work, you can look at this. These are real physical models here. Let's see if I could make these a little bit bigger. There we go. Physical models. This is an inertia, sorry. And you can see here what we have is a program that's real animation. So what it does is starts out with two spheres, these little particles. Some of them go through the big spheres, other ones collide with it. And we show that if I push them a little bit toward each other, that the pressure differences, the number of particles hitting on the opposite sides of those big circles, will tend to make them come together. And that's the idea of a particle model for gravity. Again, we're not here to talk about whether or not people believe this or this is viable, but this is a viable idea for gravity. Actually, when you take the same model and get rid of one of the objects and just let this object be pushed in one direction, in this random field, it still keeps moving. So in some sense, this is a real calculations using the idea that these little particles or these gravitons move through some of them move all the way through the object, some of them hit the object, that actually even inertia can be explained. So gravity and even inertia can be explained by a particle model. So I thought to myself, okay, what other forces have I been looking at and what I've collected over the years? And then I remembered, Nel Deneu's magnetism experiments, his underwater experiments. So if you're not familiar with Nel Deneu, he's a Romanian scientist who I believe lives in Thailand now. He does this amazing experiment in his daughter's little inflatable swimming pool where he has two rotating cylinders in the pool. And what he shows is what he thinks is a physical model for magnetism. Let's take a look. This was back in 2006.
Rotating completely submerged in water. Here we have two identical cylinders completely submerged in water and connected by two flexible hoses to two identical electric motors. The electric motors will be driven by a common 12 volts car battery. In one case, the motors will rotate in opposite directions, therefore the cylinders will rotate in opposite directions in water. In another case, the motors will rotate in the same directions. Therefore, the cylinders will rotate in the same directions in water. In this experiment, we're going to start the motors, which are going to rotate the cylinders in opposite directions. Let's see what happens. We start motors now.
So they're twirling in opposite directions.
We see that the cylinders attract each other and now are sticking to each other. Let's try to separate them.
So it's like the directions being opposite are sort of like north and south poles of a magnet coming together.
Oh, we see them attracting each other again and sticking to each other. Let's stop the motors. We observe that the cylinders are coming back to their original positions. And now let's start the motors again. We observe that they attract each other again and stick to each other now. Let's stop the motors now and conclude that cylinders rotating in opposite directions, submerged in water, attract each other. In this experiment, we're going to rotate the cylinders in the same direction and see what happens. Let's start the motors now.
Yeah, you can see them repelling.
Observe that the cylinders repel each other. Their relative distance is increasing. Let's try to push them against each other and see if we can reduce the distance. And what happens if we reduce the distance?
That's incredible. When I saw this, it blew my mind.
It's quite difficult to make them approach each other. We see that there is a force which is acting so that they repel each other. This force is
That to me,
due to the water, which is set in a motion of rotation. Let's start the motors now.
that to me was amazing. Do you remember, Dad, when you first saw that?
Yeah, yeah. And you're right, because you initially won't expect that to happen, but it doesn't take long, and you start thinking about what's happening with the spinning, which way they're spinning, which way water moves because of the spinning. Then you can talk yourself right into that diagram you're just showing. When you have them spinning opposite, then there's repulsion in between the two cylinders on the right, and the two arrows are hitting each other, pushing the water and causing them to spin away, as you see in
The
those
disturbances.
spirals.
Let's take a look at this one where he gets a little bit more sophisticated. He has two cylinders, and they are actually spinning horizontally, and they act eerily like two magnets that he'll show here. So let's take a look at this. So you can see here that they're putting these magnets, together, and you can see the north and south attract. So you can see that they are going in the opposite directions. You can even see them, and they're spinning, and they're attracting just like the magnets attract. Now he's putting them together, and the opposites on each side attract or repel, and you can see that they actually repel and then find equilibrium. They turn around, and they are attracted to each other in the exact same way as magnets. That's really incredible. It really is incredible. So from this, I came up with the idea, well, what is magnetism really? A magnetic field, it's just orbiting particles. They're just particles that are orbiting. Now, they don't have to be a circular, perfect orbit, but they are going around in a circuit, right? Around and round and round. And that when you get them, in this case, in opposite directions, you notice, as my father said, that in the middle, those particles are going in the same direction. So the idea that these come together is, we'll talk about that, why that is. But this is a model for magnetism, meaning what you have are just orbiting particles and in the same direction that causes things to come together. Again, we're not explaining how that is now. I'm just coming up with how I came up with motions, what we call these four universal motions. And then if you go down and you look at, now that they're in the same direction, which you'll see here, you'll see as they come together, there's going to be collisions basically, or there's going to be fighting, and that will cause the repulsion. So we got we've got light with my father, gravity that was already there, the gravitons, and then these particles, which would be magnetons or whatever you want to call them. And all that is basically are particles that are going around in an orbit, and that was what we would call a magnetic field. So the last motion I thought about was electricity. And the person that got me thinking about this was Glenn Borchert. Glenn Borchert had a book called The Universal Cycle Theory he wrote with Steve Putz. And in that, he talked about neomechanics and the infinite levels of the universe. But more importantly, after I read that book, and that's another thing we'll talk about, not in this video, I talked to him about what do you think electricity is? Because, it goes the speed of light, and he said, well, it's got to be kind of like light, but it's just simply moving in wires. And he has ether. His model is ether. So ether would be a medium out there, and light would be waves through it. Of course, I have a problem with ether keeping light waves within a wire, why that would stay. But the idea was, it didn't matter. It stuck in my head about just the flow, that these particles are just flowing from one place to another. And in fact, if you look at lightning or anything like that, it's a flow. These particles would go in one direction, and that would make sense. So what I would say, okay, electric motion is basically an electric circuit. We're just guiding particles, the electron in this case, what people call the electron, and they would go around a circuit. So if you put all those things together, if you put all those things together, you have what we now call the four universal motions. But at the time, we called it the particle model, and these different motions were gravitic motion, gravitic motion being random motion, magnetism being orbiting motions, electricity would be just a flow of particles in a direction, and light would be a waves of particles in one direction. So that's kind of how we got everything together, all these four motions together, from my father's inspiration to me then going and looking back at all the things and the conversations I've had with people and collecting things like, Nell Deneu's underwater magnetism, and then my conversation with Glenn Borchert that this is really a flow in one direction, that electricity is. We got what we call our four universal motions, fourmotions.org. You can go to the website. And that became the part of our book. In fact, when we were writing our first book called Principia Mathematica 2, a complete toolkit for hacking the universe, you notice we don't talk about the four universal motions, although we have them on the cover. So that's how we got there. And what we found out about those four motions, well, we'll talk about that in our next video. That's going to really blow your mind.